Hey everyone, I am Shuchi. In this video, we will work on propositional logic on Python. As usual, I am using Jupyter Notebooks on my browser. And let's start. For the commands we are using today, you will need to import a library called logic.py, the link to which is given in the description. It contains some code to represent propositional formulae and functions to perform operations on them, and has been created by Andrew K. So thank you for that, Andrew. A proposition is a declarative statement that is either true or false, and the building block of logic. Variables can be used to represent propositions. So let's create some propositional variables using the operation vars, with a list of strings as the names of the propositional variables. So now we can check what is P. P is a proposition, and so are Q and R. Using these propositions, we can create formulae. So let's try that. Say F1 is equals to P or Q, and not P implies Q. When we display F1, it shows that F1 is a proposition in itself. We can print the truth table for the formula F1 using the function print_truth_table. And we have the truth table for F1. Now let's check if it is a tautology, that is, a statement that is always true. This can be done using the isTautology function, which, as expected, results in true. Let's create a couple more formulae, say F2 and F3. F2 is P and Q implies R. And F3 is P implies Q implies R. Now we will check if these formulae are tautologies. As we can see, both F2 and F3 are not tautologies. We can also check if a formula is a contingency. That is, it has at least one true and at least one false. So let's try the is contingency on F2 and F3. The result for both the formulae is true. Next, we will print the truth tables for these formulae. We can see that both the truth tables are the same. Does that mean that both the formulae are equivalent? We can check that too by writing F2 equals to F3. The result is true, so yes, the formulae F2 and F3 are equivalent. A contradiction is a conjunction of a proposition and its denial, and the law that they both can't be true at the same time. Let's try the operation is contradiction on P and not P. The result is true. That proves that it is a contradiction. Just like we have discussed, we can create truth tables for multiple propositions. For example, P and Q. P or Q. Not P. P implies Q. And lastly, P is implied by Q. Thanks for watching.